Hello everyone, today in this video we'll be discussing the fourth module of Automata, which is the CNF and pumping lemma for context-free languages. So these two are the main topics here, and the third one, which is the closure properties of context-free languages, it is not important from the exam point of view, and it's just the theory concepts. You can go through it. There are some things like the union, cleans, closure, and the concatenation, intersection, and one more homomorphism, something it is there. Okay, so you can just go through it. I'll not be explaining that concept here. I'll be focusing on these two things which are very important from the exam point of view. And here there are many rules. Okay, you don't get so much happy that there are only two topics here. There are many rules to be understood here. So watch this video only if you have time to spend on it. Okay, because if you watch in hurry you will not understand anything. There is no point watching it. Okay, so take some amount of time, allocate it for just understanding this. Okay, if once you understood what all I have told in one go, okay, then you will be able to proceed. Okay, don't take breaks and go and come, you'll forget it. Okay, so that's all. Before starting, make sure hit the like button and subscribe to my channel. It helps me make more videos like this. And without wasting any more time, let's get started. Make sure watch the video till the end, then easily you can score more than 80% marks. Okay, this is the only video you need for module 4. Now the first one is CNF. Okay, Chomsky's normal form. Okay, you know CFG from the third module. What CFG is? Context free grammar. We understood how to write context free grammar. It is in this form, right? This is called as context free grammar. Now we have to convert context free grammar into Chomsky normal form, which is CNF. Okay, now how do we do that? Chomsky normal form has two rules. Okay, two rules. The CFG, it is only CFG. Okay, it is CFG only, but this CFG has to satisfy two rules. Okay, whatever the productions are there, this is one production, another production, and third production. These productions should satisfy few rules. Okay, what are those rules? First is that S goes to A and B are non-terminals. Okay, the capital letters are non-terminals, means the capital letters are having further derivations, and the small letters are called terminals, and they are ending means they don't have further productions. Okay, these are the ending letters. Okay, that's the difference between the non-terminal and terminal. So whenever we convert a CFG into a CNF, we have to ensure that the production is of the form either it should have two non-terminals or it should have a single terminal. Okay, these are the only two ways. Another one is there, the starting state which is there, that can have an epsilon also, and rest of the state should not have any epsilon. Okay, so this is the rule which we need to satisfy. Now let's understand how do we do this one. So in exam point of view, the question will be given as a CFG. You will be given with a CFG, and you have to convert it into a CNF. Okay, so there are few rules present. 5 rules are there. Let's understand each rule one by one. The first rule is you have to go in the same order. Okay, if S appears on the right hand side, take S dash goes to S as a new starting state. Okay, so suppose that you have been given a question like this in exam. S goes to ASA or AB, A goes to B or S, B goes to B or epsilon. Okay, now which is the starting state? The starting state is the first one which they give, that is S here. Okay, so S has appeared here also in the right hand side, here also in the right hand side. Whenever S appears in the right hand side, we have to take a new starting state as S dash, which is pointing to S. Okay, so we will be writing it as follows: S dash goes to S, and rest of the thing will be similar. This is same as this one here. Okay, this and this is same, there is no difference, only that we have to take a new starting state. Now the starting state is S dash, previously it was S. Got my point? What's the rule one? Take a new starting state if you find the starting state anywhere in the right hand side. Okay, that's the first rule. Second rule, remove the null productions except if the starting variable has S goes to null. See, I told you that the productions are a Chomsky normal form if the starting state is null. Okay, this is possible. Okay, the starting state can go to null, others can't go to null. So if you find any other production other than starting state which is going to null, like this case B is going to null, C is going to null, and B and C are not starting state, then we have to remove those null productions. How do we remove those null productions? Let's understand it step by step. Okay, for all the questions you need to follow the same rules and same sequence also, first rule, second rule, third rule, then you will be able to solve any question. Okay, so see here, what are the null productions? First, make a set of null productions. Which is the null production here? B goes to null, so I have mentioned here B. C goes to null, so I have mentioned here C. Now your next step is wherever you find B and C, substitute null there, means remove that. Okay, now let's start from the beginning. In the beginning, can you find a B and C, capital B and C? Yes, a capital C is present here. Now if I substitute the value of C as null, what will be I getting? What I will be getting? I'll be getting here ABA, right? ABA I'll be getting. Okay, now if I substitute B or C as null here, C is over, there is no other letter B here, so I'll be moving to the next one. Here I have both B and C. If I substitute B as null, I'll be remaining with C. If I substitute C as null, I'll be remaining with B. And if I substitute both as null, I'll be remaining with the null only. Got my point? I'll be remaining with the null only. Okay, that's about this one, B and C. Now is any other B or C present here? No, there are no B or C present. So now while deriving this one, I have got another null here, right? While deriving, I have got another null here, so I have to include A also as null production. Got my point? Now I have included A as null production. Now if A is null, I have to again start from the beginning and substitute all the places where A is null. Now see, A and C is null here. Okay, A and C I have to consider again. I had considered C particularly, specifically I had considered C and got this one. Now I have to consider A also. Now if I consider only A, it will be BAC. If I substitute A as null, it will be BAC, right? BAC. Now if I substitute C as null, then I got this one. If I substitute both A and C as null, what I will get? I'll get BA. Okay, got my point? That's how we will be writing here. And after we have substituted the value of A as null, then we will be removing the null from here. Okay, and B also we substituted the null wherever we had to, so we'll remove this one as well. And C also we substituted as null, so we'll be removing it. So this is the final equation which you will be getting. Okay, so this is the one which is converted where the null productions are removed. So the rule number 2 is satisfied. Okay, got my point? Just follow the same rule. First get to know which are going to null, note down there, and wherever you find that letter in any combination possible, you have to make it as null. After that, substitute the value of null in those places and find out what all combinations you can get. In that case, if you get another null in between, like how we got for A, do the same, repeat the same with A also, along with the other null characters combination. Whatever combination you get, keep it. Okay, so this is how you calculate or convert after removing the null productions. Okay, this is the rule number 2. After you have done rule number 2, there are no null productions, then next you have to check for unit productions. Okay, what do you mean by unit? Unit means 1. Now what do you mean by unit is, see here, S goes to A and B, capital B. Okay, and capital B goes to capital A and small bb. A goes to A and BC and B. Now S goes to B. This is called as a unit production because a non-terminal goes to a non-terminal. It should be a single non-terminal. If two non-terminal means it's fine. If it was like BB, it would have been fine. I would have not have any issue. But if it is only a single B, there is an issue. That is called as unit production. Note down the unit productions here. S goes to B, B goes to A goes to B. These are the unit productions which I have noted down. After you have noted down the unit productions, you have to remove them. Let's have a look how to remove them. So to remove the unit productions, you have to follow a very simple rule. Start from the beginning. Okay, first I'll focus on S goes to B. Okay, S goes to B. If I have to remove, what I will do, I'll just again write the same thing here. Okay, I've written the same thing here, and now what I will be doing is I'll be considering each one by one. What is my first unit production? S goes to B. Now to remove the unit production, instead of B, see, apply your common sense here. The common sense says that if S goes to B and B goes to the following, I can directly write S goes to the following, right? So that's what I will be doing here. S goes to the following, right? I can directly write it like this. Next, after this is done, you have to go for the next one. Okay, here B goes to A. Here S goes to A is there, but I'll come for it again. Okay, so B goes to A and A goes to these following things. Now if B goes to A and A goes to the following things, I can directly write B goes to the following things and BB here, right? So instead of this A, I can substitute this part here. So that's what I'll be doing. BB I'll be writing here, and this same thing I'll be writing here. This is substituted for A. Now B goes to B, there is no point. B goes to B, it will go on infinite. So wherever it goes infinite, just remove it. Okay, if it's going to the same letter, just remove it. Now I've reached this point. Okay, now A goes to A, B, C, or B. A goes to B and B goes to the following. So you can directly write A goes to the following here. So I'll write it A, B, C, and B, B. Now you can observe A is repeated, B, C is repeated. I can remove the ones which are repeated. So these two I'll remove it. B, B is remaining. I'll write B, B here and I'll remove from here. Okay, so A and B is done. Now again I will go from the starting and see if I have got any new unit productions. So S goes to A goes to the following, right? So I can directly write here this thing. Okay, so observe carefully. A is present here, no. Okay, so I'll write here A, and BC is present here, no. So I'll write BC, and BB is present, it's present, so I'll not write it again. So this is the final answer which you get after removing the unit productions. Okay, so this is the sequence you'll follow. From the top you'll go and you'll remove all the unit productions, and you'll come back again and check if any unit production is there. You'll keep on doing until you remove all the unit productions. Okay, now moving on to the similar type of example. Here what we are trying to do, let me insert some space here. Okay, so see here also the same thing. Okay, just keep following. What we are going to do, the same rules we'll follow. First, find out the unit productions. The unit production B goes to C, C goes to D, D goes to E. 3 unit productions are present here. Now start from the first unit production. B goes to C. Instead of C, I can substitute it as C goes to D, and D I can substitute as D goes to E. E I can substitute as E goes to A. So I can directly write here B goes to A. Right? Eventually it's going to a terminal here. So I can directly write the terminal in this spot here. Right? After that, C goes to D. The next one, this is done. C goes to D, D goes to E, E goes to A. I can directly write here A. D goes to E, E goes to A. I can write here A. Now, after this is done, can you find any other unit production from one non-terminal to a single non-terminal? There is no such unit production present here. So therefore, we have converted or removed the unit productions from the given CFG. Now, after this is removed, you have to check for one next rule. Okay, next rule, what it says, you have to remove the useless productions. Okay, what do you mean by useless? See, S goes to AB, A goes to A, B goes to either B or A. I am nowhere reaching C, D or E from the starting state. Am I able to reach here? No, I'm not able to reach. So these type of things are called useless productions, which we have to remove. How do we remove them? Just erase it from the screen. That's all. Right? You have to just erase it from the screen, then it will be removed. That's how you follow the next rule. Okay, but it's not always as simple as erasing from the screen. You have to follow some other rules also, because it might be having a C in between here also. So we'll be discussing what kind of rules can come in other type of questions. Okay, so moving on to the next rule, which is removal of useless productions. Okay, so see here, this question is given to us, and we have to remove the useless production. Okay, so to remove the useless production, we need to know which production is useless. Okay, so finding out the useless production will go in a reverse way. That is more easier. First we'll find which is the useful production. Okay, how do we know which is a useful production? All the terminals are useful. Okay, listen to me again, all the terminals are useful. So the terminal is A here, terminal is B, all the terminals are useful. So make a set here and write A, B as useful. Okay, after that, A and B, from which letter I am going, which non-terminal I am going through A and going to B, S and A. So S and A also become useful. Got my point? Like that you have to calculate which are the useful symbols and put here. Now after these two, S is useful, A is useful, you have to check if B is useful or not. How do we check if B is useful or not? Now B goes to AB. Now A, B both are coming in this set or not? A is coming in this set, yes. Capital B is coming in this set, no. So we cannot consider this for determining this is useful. C, is C present in this set? No. If it is not present, these both are not present, therefore this is not useful character. This is not useful production. Okay, moving on to the next one, C. AC, is AC present here? A is present but C is not present. B, is B present here? No, it's not. So therefore it is not useful character. or useful production. So therefore we will be removing it, we'll be just erasing it from the screen. Okay, so this is then we'll also have to check if B and C are not useful, wherever either B or C has come, that will also become not useful. Okay, B and C are not useful, right? So wherever B and C, or B or C, either one, if B has come, then this has become not useful. Okay, okay, if B has come, this has not become unuseful. Here A and B, either one, either B or C, if it has come, if it was AC also it was not useful, AB also is not useful, because B has come, then it automatically made A also not useful. Okay, so this also we need to remove. So what we are remaining with, S goes to A, we are remaining with S goes to A here, and BC is removed from here, A goes to B. Now after removing the ones which are useless productions, you have to go for the second thing. The first thing is derivability. Derivability is just what I explained here. Are you able to means get here the useful symbols here or not? Based on that, categorizing it as useful or not, whatever I explained till now, that is called derivability. After that you have to go for reachability. What do you mean by reachability? See, S is the starting state. I'll start from here. Obviously it goes to small a terminal end, that's it. A, I'm not reaching anywhere. A is not present only here. So this is unreachable state, right? Wherever it is unreachable, remove that as well. So once you remove that, you will be remaining with this one, and this is your final answer. After removing the useless production from this CFG, you will be remaining with this production, which is like the one which is not having any useless production. Okay, let's understand this using a second example. Okay, so in this example, useful symbols, terminals are A and B. Any other terminal? No. So A and B are terminals, and A is going from A, capital A, that is also useful symbol. Now we'll be checking each one by one. S goes to A, B. Okay, B I'm not sure, it's not present here. A and C is also not present here. Okay, we'll keep it as like that only. Now we'll see for all of them. Okay, what if after considering B I got this as useful symbol and I write here B, because of writing B this also becomes useful. So we have to check always first. Okay, don't hurry, first you check. Okay, so here A is useful, we need not consider it. Second, B goes to BBA. Is BBA present in this set? Yes, BBA is present, therefore this is useful symbol. And if one also I find here as useful, that letter will become useful, so B also became useful here. What about C? C goes to A, B, C and A. C is present here, no. A, D, B, is D present here, no. So wait for some time. Okay, again we will come here. D, B, D, no, D is not present, C is not present, so we'll go back here again. Now S goes to A, B. A, B is present here, therefore S is also useful. S is useful, A is useful, B is useful. We'll come back to C. Now after going through the rotation, coming back again, we couldn't enter C here while we went back here, right? So there is no way, how many times I go, I'll not be able to enter C or D here, right? So therefore these two are the useless production. C and D are what? Useless productions. So we will remove C and D from the screen. Now if C and D are useless, the ones which are all having C and D, that all become useless. So A, C becomes useless here, and any other one which are useless here, the no other are useless. Okay, fine. So what will be my final answer? S goes to A, B. Okay, and A goes to A, B, B, A, and A. B goes to A, B, and A, B. Okay, so these are the final states after removing the useless productions. Okay, after that the four steps, you have simplified the grammar which is given in the question. When they give, you have to reach this state after applying the rule 1 to 4. You have to reach this state. This is the simplified CFG. Okay, first step is to get simplified CFG by following the first four rules. The simplified CFG only can be converted to CNF. Okay, simplified CFG can only be converted to CNF. This is the rule. Unless it is simplified, you cannot proceed, you will get the wrong answer. So first follow the rule number 1 to 4, make it simplified, then you are ready to convert it into CNF. let's have a look at the conversion, how we have to do. Okay, so after applying all the above rules, we obtain a grammar ready to be converted to CNF. Now let's see how do we do the conversion. Okay, so see here, S goes to A goes to AAB, B goes to AC. This is the thing which is given to us. Now we have to convert it into a CNF. What does CNF say? First check if it is already CNF or not. Okay, like that question they won't give, or if it's already CNF, that's a stupidity, but we have to check it always. Okay, so here it will be S goes to ABA. What is the rule? Rule is that the production can be either two non-terminals or one terminal. Okay, so is this two non-terminal? No, it is having two non-terminal, but along with that another terminal is there. This is not the right production. This production AAB, three terminals are there? No, only one I need. And this one non-terminal goes to two non-terminal. This is the only one which is having satisfied the rule. Okay, this has satisfied the rule. Now we have to convert the following into the CNF. Okay, now to convert it into the CNF, the first step you have to do is, see, this stage you will reach after going through all the above steps. Okay, all the above steps which are there, after that you will come here. Okay, first you have to check for all the above rules. Okay, after that only you will come here. Now after you have come here, what you have to do is to convert it into the CNF. The first step is identify the terminals. Okay, what are the terminals here? Terminals are, make a set of terminals A and B. A and B are the terminals. So for each terminal define a production. X goes to A, like that you define for A, and Y goes to B, like that you define for B. Okay, now after defining the X and Y for the following, then you have to substitute the value X with A and Y with B. Wherever you find A, put X. Wherever you find B, put Y. Okay, so A is present here, I'll put it as X, and A is present here, I'll put it as X, and B, wherever it is present, I'll put it as Y. Okay, this was X. So here I have removed all the terminals and I have taken it separately. Now after does it satisfy the CNF, which is having going to two non-terminal? Here it is going to three non-terminal. Here also it's going to three non-terminal. Okay, so we cannot go with that. You have to change it. Okay, you have to make it as two non-terminal. So for that, what I will do is, I'll take the first two or the last two, any two you can take, first two or the last two, and make it as another production. Okay, so I'll take AB as W goes to AB, I'll take it as another production here, and I'll take it as WV. Okay, V, any letter you can take. Okay, XX I'll take it here. Now instead of AB I can put W, so here I'll put it as W, and instead of XX I can put it as V. Now it is of the form CNF, because S is going to two non-terminal, A is also going to two non-terminal, and the B is going to two non-terminal. Okay, so here we have converted it successfully into the form where it is having the CNF. Okay, let's have a look at a similar type of example so that you understand it more better. So in this example we have been given with this grammar, and we have to convert it into CNF. Okay, so CNF rule is either S goes to AB and S goes to A, or any terminal it has to go, or two non-terminals. Okay, so here which all the rules which it satisfies. First, note down the terminals. Okay, which are the terminals present here? The terminals are A, B and C. Now three terminals are present here, A, B and C. Okay, now for each of these terminals define another variable. Now for A I'll define x goes to A, for B I'll define y goes to B, and for C also I can define, but it's already present here, so I need not define it again. If C also had some other things like dx, like that and all it had, then I had to define it separately, but since C only has a single variable C here, so I need not define it separately. Okay, so I've defined the first thing, which is the terminals as non-terminal here. Okay, x goes to A, y goes to B. Now wherever I find A and B, I'll substitute with x and y. Okay, so A is present here, I'll put it as x. A is present here, I'll put it as x. A is present here, I'll put it as x. B is present here, I'll put it as y. A is present here, I'll put it as x. and B is present here, I'll put it as Y. Okay, so this is okay, B and E is also present here, Y, and here also it is Y. Now I've converted it in the form of all the non-terminals. Now we have to satisfy this rule. Okay, here in this rule A, B should be there, like two non-terminal should be there. This is satisfied, two non-terminal, three non-terminal are there, we have to change this. Two non-terminal, this is a single non-terminal here. Okay, this also needs to be changed because it cannot be having a single non-terminal. Therefore, if it's having a single non-terminal, it's better to keep it as A only. Okay, A and B only. Okay, because again, if it's it will reach into the problem of unit production again. Again, A is going to X and X is going to A. Therefore, I can directly write A is equal to A. If it is having two letters combined, then only you'll have to substitute. Okay, if it's single, keep it same only. Okay, now after that, this I have to change and this I have to change, right? How do we change this and this? Now I can take A and B as W and V. W as AA I will take, and V as BB I will take. Okay, very simple. Instead of AA I'll write it as W, and instead of BB I'll write it as V. Okay, so this is your final answer, which will be okay, not this one only, the whole thing. Okay, you have to consider the whole thing. This is your converted CNF. Okay, this is in the form of CNF. Okay, for any question, just follow these rules and you'll be getting the answer. Okay. Moving on to the second topic, which is pumping lemma for the CFL. Here we will be doing the similar thing which we had done in the previous module, where we use the pumping lemma for the regular languages. Now we'll be doing it for the CFL. So the rules remain same, slight differences are there, so pay attention. For any string z belonging to L, we can write z is equal to u v w x y. Okay, so the language will be given to us and we will be forming a string here. Okay, a string, suppose that the string is z. Okay, we form the string z, and that z has to be divided into 5 parts, u v w x and y, such that the following rules will be satisfied. Okay, so we'll be looking at each of these rules by using an example. Now see, the question given is, using pumping lemma, show that the following language is not context free. Okay, so the question given is L is equal to 0 power n, 1 power n and 2 power n is greater than or equal to 1. Now let's take the value n is equal to 3. So the following string will become 0 0 0 1 1 1 2 2 2. Okay, now I have to divide this into 5 parts, u v w x y. Okay, now to divide it into 5 parts I have to satisfy some rules. Okay, so I have divided it such that the middle part v w x will be minimum. Okay, so that the length of vwx, okay, the length of this, how much it is, 3, that should be less than or equal to n. The vwx, that length should be less than or equal to n. So I have to take a means string is such that that satisfies that condition. Okay, and u and y can be as much big as it wants. Okay, so next, we have to also satisfy v and x should not be empty. Neither v should be empty nor x should be empty. It should have some minimum letter present. Okay, so in this case, v and x, if you multiply, it will not become 0, so it will not become null. Therefore, each of these is not null. Okay, after that, what you have to do is um, take z is equal to u v power I w x power I y. V and x will be pumped here. Okay, so the string will be writing here, this is u v w x y. Okay, now pumping I, let's take I is equal to 2. Once we take I is equal to 2, what will happen, the I value will become 2, means 0 power 2 is 2 square, right? So 0 0 and 1 will be here only, and this 1 will become twice, so this one became twice here, 1 and 2 to 2 will be here. Okay, so this is after the pumping. Now count how many zeros, ones and twos are there. 4 zeros are there, 4 ones are there, and 3 twos are there, which does not belong to 0 power n, 1 power n and 2 power n. The number of 0 1 and 2 should be equal, but that is not happening in this case. Therefore we conclude that L is not context free. Okay, let's see another example. Prove that L is equal to a power j, b power k, c power j, and d power k. J and k both can be greater than or equal to 1, is not context free language. Let's take j and k as 3. You can take different one also. So for simplicity purpose, we will be taking 3. It will be easier to prove the pumping lemma. So after taking 3, A will be repeated thrice, B, C and D also will be repeated thrice. divide it such that u will be a, v will be b, w will be b, c x will be c. So u v w x, this length will be 3. Okay, so that it will be less than or equal to the value which we have, jk. Okay, which is less than or equal to n here in this case. Next, so here we'll be having the y c c c c c d d d. Okay, so these lengths are also given here. After that, we have to check if it is not equal to, means both v and x are not equal, obviously. I mean v and x both are not null, it's not null, then we will be pumping it. Okay, after you have taken this one, v power I, what is v? We have taken b, and w was b, x was c, c power I. Now let's take I is equal to 2. After we take I is equal to 2, here we will be obtaining 2 b's here for v power I, x power I will be getting 2 c's. Count the number of a, b, c and d. We will be getting a power 3, b power 4, c power 3, d power 3. Here the number 4 and 3 are mismatched because of pumping, which leads to the conclusion that L is not context free language. Okay, so it had to satisfy this rule for it to belong to L, right? But it did not satisfy that rule, so therefore it does not belong to L, and L is not context free. Right? If you want this video helpful, please do like and subscribe, and thank you so much for watching. I'll see you in the next one.